Hi everyone, welcome to another video in this playlist looking at 10 of the key topics around the grade B mark that we're going to be looking to pick up marks for in our Edexcel GCSE exam, and these will kind of complement and supplement the grade C topics that we've already worked on to ensure that that grade B is something that's well within your grasp. Today on this video we're going to be looking at the second in this list of 10 key skills, and that's inequalities. So let's start by taking a look at some of the typical inequalities types of questions, and I've got some here. So here we go, and it says question part A, on the number line below show the inequality. And when we're talking about inequalities, we're talking about these signs here. Kind of, you've probably been taught them as knowing them as crocodile mouths, and these are, if you like, a replacement for an equal sign. So it gives y a set of values that it could be rather than a specific value that it is. So let's read this out and then let's think about how we're going to represent this on the number line. So the first side on the left there, if I ignore this part for now, it says y is bigger than negative 2. And I know that it says it's bigger than because the y is next to the larger end of the crocodile mouth. The negative 2 is next to the smaller end. So y is bigger than negative 2. The first thing I'm going to do is I'm going to highlight the value of negative 2 by putting a circle on it. And before anyone says, but hold on, it says it's bigger than negative 2, it can't be negative 2, we'll talk about how we identify to anybody that negative 2 is not included in the range of values. But if you were thinking about putting it at negative 1, what you've done is you've eliminated all of these values here that it could be. So for example, minus 1.5 or minus 1.6 or minus 1.773. Okay, so we're going to say that it can go all the way up to negative 2, so minus 1.9999999, but it's not actually going to be the exact value of negative 2. On the other end of our inequality expression here, we've got y is less than 3. Because the y is next to the smaller end of the inequality sign. So I'm going to put a circle at the value of 3, and then because this expression is saying that it's all the values between these two parameters, I'm going to join them up with a line to suggest that any value along this line could be the value of y that's going to be taken. Now, we mentioned a moment ago, how do we show to anybody that minus 2 is not included, and again that 3 is not included? Well, we do that by just leaving this circle hollow. So just a note there for your revision, a circle which is left hollow can mean greater than or it can mean less than, but a circle that's been coloured in would also be included. So that would be greater than or equal to and less than or equal to. So there's our final answer for part A, and that would get us one of our grade C, B, GCSE marks. Part B then is the other way round, and the number line's already been drawn for us, and this time we've got to write the inequality that represents this set of values. So the first thing you'll notice here is we're talking about the algebraic term x, so we're going to have an x in our answer. We've then got our two values, minus 3, which I'm going to put on the left-hand side because it's down the far end of the scale here, and positive 4, which I'm going to put on the right-hand side. And now I need to make a decision on the set of values that x represents. Well, we've got our minus 3 on the left, and all of the values represented on the number line are to the right-hand side of it, so they're bigger than this. So I can say that x is greater than minus 3, because it's all of the numbers here which are all bigger than minus 3, it's none of the values down here. At the other end of the spectrum, at the 4, the line is representing the values that are smaller than 4. It doesn't go beyond it, so I can say x is smaller than 4. And then the final thing we make reference to, which is the notes that we made up here, because the 4 is coloured in, it means that x could be equal to 4. So we've now got x is smaller than or equal to 4. But at the other end of the spectrum, because the circle at minus 3 is left hollow, it can't be minus 3, it has to be bigger than minus 3, so it kind of starts technically at minus 2.99999. So this would be our correct answer. Finally, for this question, we've got to solve an inequality question, and generally speaking, before this kind of causes you too much confusion, this is just like solving a normal equation. And the method that I tend to use for this is the balancing method, and therefore we're going to start with everything on the left and everything on the right, and we're going to kind of assume that they're equal, even though we've got the inequality sign that says that the left is bigger than the right. So I want to get t on its own. Two things are preventing t being on its own, this multiplied by 4 and this subtract 5. So I start by getting rid of subtract 5 by doing the inverse operation, which is to add 5, but of course I do that to both sides of the equation. So my new line now says 4t, the minus 5 and the plus 5 eliminate each other. I've still got this inequality sign in the middle, and then I've got 11 plus 5, which is 16. And then I just start the whole process again. What's stopping t being on its own? Well, we're just left with this 4 that's multiplying it. So 4 multiplied by t, so to get rid of multiplied by 4, I divide by 4. And therefore I need to do it on the right-hand side as well. And so I'm left with t, because the 4, which is multiplying, and the divide by 4 cancel each other out. And 16 divided by 4 is 4. So we have our answer, t is greater than 4. One of the biggest mistakes I see students make at this final stage is when they come to write the answer in, they either just leave it as 4. Well, that's no longer correct because t is a range of values, it isn't a specific value. So notice what we've done over here. Or sometimes, just kind of through typical work around this, they go and put t is equal to 4. And t is not equal to 4, t is greater than 4. So we have to make sure that we put the inequality sign in that came out of the equation. And there's always kind of a good use of checking here. We're saying t is greater than 4, so let's see if that works. So t can be anything bigger than 4, so let's start with 5, because that would work according to this rule. Let's substitute 5 in here. 4 lots of 5 is 20. 20 subtract 5 is 15. 15 is greater than 11, so we would probably say with confidence that we've selected the right set of values. Now, there is one other type of inequalities question that does come up in your GCSE, and it links to one of the videos that we looked at in our playlist when we were looking at grade C topics, and that's graphing inequalities. So what we've got here is a set of axes with some grid references on it. At the top here we've got 3 inequality statements, and we're being asked to represent them on here and find a region, so a space, a section of the graph here that satisfies all of these inequalities. What I would do is I would start by pretending these weren't inequalities, and I would just represent them as normal straight line graphs. So instead of x is greater than or equal to 2, I'm going to say x is equal to 2. Instead of y is greater than or equal to 1, I'm going to say y is equal to 1. And instead of saying x plus y is less than or equal to 6, I'm going to say x plus y is equal to 6. And so I'm going to represent those 3 new statements on the graph. So x is equal to 2. Well, what does that say to us? It says that in terms of a coordinate, I don't care what the y value is, but the x value has to be 2. So if we kind of set that as a set of coordinates, just to help us visualize that better, coordinates are x followed by y, so the along the corridor value and then the up the stairs value. And this rule's saying us the x number, so the one at the beginning, has to be 2, but the y number can be anything we want it to be. So has to be 2, anything we want it to be. Has to be 2, anything we want it to be. So I'm just going to make some numbers up here to prove a point. So I'm going to put 0 in there, I'm going to put 4 in there, and I'm going to put 7 in there. Let's check, do they all obey the rule? Well, the rule says x has to equal 2. X does equal 2, doesn't say anything about y, so all those points would work. If I plotted them then, so 2 along and 0 up, well that goes there. 2 along and 4 up, well that goes there. And 2 along and 7 up, well that goes there. So actually we end up forming a pattern on our points where we have a line here, and I'll just draw that a bit thicker than I usually would if this was a real question so that you can see it definitely on the video. I have a line there, and all of the points on that line represent x is equal to 2. So any point on that line, if I stop, the coordinate would have the x value as 2 and the y value would be changing. And you'll notice that it kind of runs intuitively the wrong way to what you would expect an x value equation to look like, because our x values typically run across the page, but that you need to understand that the values that on that point are going up and down, on that point up and down, and so on and so on. So if we did the same for y equals 1, this is saying to us we don't care what the x coordinate is, but the y value has to be 1. If you're a little unsure about the line that I'm just about to draw, then follow this same model, create some coordinates, plot them, see the pattern that's formed, and you will find that y equals 1 ends up becoming a horizontal line coming out of the y-axis where the value of 1 is recorded. So this line now represents y is equal to 1. The final equation here looks a little trickier, but it's really straightforward if you kind of think about it logically. It says to us the x coordinate plus the y coordinate have to total up to 6. So let's just kind of play around with those numbers and see what we get. So if x was 0, then y would have to be 6, because 0 plus 6 is 6. So 0, 6 would be one of the points on the line. If x was 1, y would have to be 5. So 1, 5 would be a point on the line. 2, 4, 3, 3, 4, 2, 5, 1, 6, 0. Those would be all the points that represent a total of 6 when I added the y coordinate with the x coordinate. So I will end up with, as accurate as I can there, a diagonal line there, and all of the points on that line represent where x plus y is equal to 6. Now I need to get on with the question, which is express the region that satisfies them. So let's go back to our first one. X was equal to 2. Well, every point on this line is where x is exactly equal to 2. And I actually wanted in the original question x to be greater than or equal to 2. So if we now think about our x scale, which values are greater than 2 on the x scale? Well, they're the ones to the right hand side. So I can eliminate, if you like, all of this section here. So I'm just going to eliminate that in a different colour so I can show you what I mean, but obviously you're not going to do this in the exam because you might, as the question says, look like you're shading the wrong region. So I don't want any of this region here now, because this region here is where x is less than 2. So I'm going to ignore all of that region. Let's look at our second one. Instead of y equals 1, which is this set of values here, I want y to be greater than 1. So looking on our y-axis, here is where y is equal to 1, so greater than 1 is going to be the numbers above it. So again, we've got a section of the graph that we can now rule out, which is this section below here. Again, don't do this in the exam, this is just to help you visualise this on the video. And then we have x plus y is equal to 6 is on this line here. I want x plus y to be less than 6, so that's going to be logically numbers below the line. So again, in terms of eliminating a region, I'm going to be able to eliminate the space up here. That therefore leaves me with the area I would shade in. So I haven't done any of this red shading, that was just to help you visualize this. The region that works for all three of the graphs in the inequalities is the space inside this triangular area here. So that would be my perfect GCSE answer. One thing else to mention here, and then we'll finish with this video on inequalities. You'll notice that I drew solid lines. That's because all of my inequality equations at the beginning had inequalities of them of greater than or equal to, or less than or equal to. Just a point of note here, if we're using or equal to, the line is a solid one. If it was just greater than or less than, the line would be a dotted one to indicate that the values on the line aren't actually included. A bit like when we did our inequalities on a line and we represented it or equal to by shading it in, and we represented not equal to by leaving it hollow.